question number 1. So question number 1 wants us to determine if the relationship is a function or not, okay? So here we have 3 examples, okay? So in each of the example, we need to determine whether or not it's a function or not, okay? So whenever you have a graph, that's the easiest way to try to figure out if it's a function, okay? Because to test if a graph is a function, you do something called the vertical line test, all right? So the vertical line test states that if I was supposed to draw a vertical line, so that's a straight line going down, in between my graph, and if it hits it more than once, then it is not a function. So when I look at this, it hits it only once. So would you state that this is a function, guys? Yes, you would. All right. So again, guys, we see that it hits it once. So because it does hit it once, that means that this is a function. All right. So again, guys, this one would be a function. All right. So what about the next one, guys? So what about the next example? Okay. So when we look at the next example, we see that we're given some ordered pairs, all right? So ordered pairs are x and y values, okay? So whenever you're given ordered pairs, your x values cannot repeat, okay? If your x values do repeat, then it is not a function, all right? So your aim is that because the question says which one is a function, we're looking for when the x values do not repeat, okay? So again, whenever you have ordered pairs, x values cannot, so again, they cannot repeat. Okay, so again, they cannot repeat. Okay, so when I look at these ordered pairs, I'm going to be looking at the x values, and if they repeat, that means it's not a function, all right? So when I look at this ordered pair, I see a 7 for the x, a 5, a -7, and another +7. So because I see that the 7s repeat, would this be a function? No. And the reason it's not a function because the 7s repeat, okay? So this is not a function, okay? So what about the next ordered pairs? Well, I see a -3 and another -3. So because of the -3s, is this a function? No, it is not a function, all right? What about the next one? So I see a 5, a -6, a +6, and a +3. So those x values are not the same. So would this one be the function? Yes, it would be, all right? Because none of the x values repeat. And why would the next one not be a function? Because which value is repeating? We have a -4, a -9, a 7, and a 7. So the 7s repeat. So that is why this is not a function. Okay? So let's look at the next one. So the next one, we're given some mapping, all right? So it says, explain if the mapping represents a function, okay? So whenever you see a mapping, all right, it's telling you that set A is correlating to set B in some way, all right? So set A would technically represent my X, all right? And set B would represent my Y. Well, some things you would need to know is that set A or your X can be considered your input, okay? Because that is what you're inputting to evaluate to get your Y, all right? And set B or your Y value would be your output, okay? Because that would be your result, okay? So whenever you want to determine whether you have a mapping that is a function, you cannot have where one thing from your set A or from your X is going to more than one things in your set B or your Y, all right? So the only time when it's a function is when it's 1 to 1, which means that only one X value is going to one Y value, or if it is many to 1. All right? So those are the only times when it is a function, okay? So if you look at this order, this mapping, all right, we see that the 8 is going to only the 2, but we see that the 7 is going to the 4 and going to the 3. So that means that this will be considered something called one to many things, because one thing is going to many things, all right? Anytime when you have one thing going to more than one thing in your set B or your Y, that means that this is not a function, okay? So again, this one would not be a function, okay? And here's the reason why it would not be a function, okay? It would not be a function because there is one of your set A, all right, which is your input. So there's one thing in your set A, which is your input, that's going to more than one things or going to multiple things, okay? So it's going to multiple things in set B. And what is set B? Your set B would be your output. Okay, so again, guys, that would be the reasoning for why this is not a function. Okay, so again, it can only be a function when it's one to one or many to one. That means one thing is going to only one thing, or where we have many things going to one thing, okay? Where, for example, if you saw this -3 going to the 0 and the 7 going to 0, that would be a function. All right, so again, guys, just like that.